Hello and welcome to a new episode of Mostly Engineering and another part in our Enigma build series. So, welcome to this episode, and today we are going to manufacture the wedges for our reflector, so this little parts over here. And these are really important for the operation of the machine because they allow the reflector to move back and forward so that we can change the rotors. And while the machine is running, they ensure that we have pressure on all the connections and therefore ensure an electrical connection. And these are also probably the most challenging parts of the reflector build because first they are relatively small and hard to hold on to while working on them, and second of all, to machine them, this requires a 3D operation, and 3D operations on the CNC is something I have never been done before, so I don't know where the challenges lie yet, but the beauty of this project is that I will soon find out. So I'm looking forward to it. And then we had to change the plans a little bit because in the original plan the wedges sit on top of the backplate, but to manufacture these, ideally we would have needed a 30mm thick aluminum plate, but available to us is only 12mm, so slightly too short, or 15mm. So I used the 15mm and extended the wedges 2mm into the backplate, and this will give us several advantages. So let's go over to the computer and look at the design and talk about set advantages. So, and here we have the backside of our reflector drum, and as I told you, I extended the wedges into the build plate, and besides the fact that we are not just milling 2mm off our raw stock, this gives us two main advantages. Now, in the old design, the wedges would be held only by 2 screws, and here we have a very tight fit. So in this design, the wedges are not only held by the 2 screws, but also by this whole edge around here, and this will give us a much tighter and more secure connection. The other advantage is in the holes. Now in the original design they are 5mm deep, and if you keep in mind that a tab can't cut a thread all the way to the bottom of the hole, that we lose about 2 or 3mm, that would left us with only 2mm of thread. And now by extending the part 2mm, we also get an extended thread length of 4mm, and this again helps us to better secure the wedges to our reflector. And with this done, let's go over to the manufacturing tab and I show you the CNC process. So, and here we have our part, and as the surfaces over here are curved in 2 ways, we need a 3D operations. And here we have lots to choose from, and I've gone to basically all of them, tested them out, run the simulations, but in the end I found that with the colors I have at hand, what are basically only end mills, adaptive cleaning is probably the best solution. So what he does is basically going layer by layer and cutting the part out, and we go with 0.3mm layer, and then for the contour itself we go with a layer height of 0.05mm. That won't give us a straight edge over here, but rather a step structure, but this will be in the same ballpark as normal 3D printing, so I know it's easily to send the steps out of the part. And if you know better options to do this, please let me know. But when we are finished with this, we will then finish the program off with just a 2D contour to cut the part out of the raw stock and finish it. So let's put this program on the CNC and see how it works out. So, and here we have our CNC wedges. So fresh from the machine, the part looks like this. So we still see the steps and a little bit of accidental anodization. And with a couple of wipes with a sanding stick and then a little bit of time on the Scotch-Brite wheel, the part looks like this. So we still have some nicks and dings, but I really like the look. And if you think about it, an Enigma machine should be 80-90 years old by now, so if it isn't perfect, it looks right. What we have to do now is drill and tap the mounting holes. And here we come to a very common problem in machining. And if you look at this part, it's really hard to hold onto and hold in a precise position. So what I did is I 3D printed this little fixture over here. And here you see the positioning lines, and this part will just fit in nice and tightly. And then the two mounting holes are in one line parallel to the surface. So it's easy to clamp into the milling machine and drill out the required holes. So let's go to the milling machine and do exactly that. So, and here we have our setup, and here we have a PCB drill, and I really like this drill because they all have the same shaft diameter, so you never have to change the collet in here or in this drill bit hole loss. And another advantage is that ring, and together with the gauge block we can use this as a depth stop for our holes. So, and here we have the finished backplate with the wedges. Now it came out really nicely, and it is really rock solid. So really nice, and you see that the reflector drum comes along nicely. The only thing left to do is now paint these and put the wiring in and then the sleeve. And with this we are basically done already. So really nice. And on this note, it's time to end the show. So if you have questions, comments, as always, let them down below, and I try to answer them as quickly and correctly as possible. And all that I have to say now is thanks for watching, and see you at the next time. Bye bye.